So today we're going to be looking at functions. What is a function? With functions, what is the domain? What is the range? What is a relation? Is a relation a function or not? We'll look at the difference quotient. The difference quotient is something that we'll use a lot when you're in calculus. It's part of the definition of a derivative. Doesn't matter if you don't understand what that is. You'll soon find out once you take calculus. We'll also look at forms of different operations, some difference products and quotients of two different functions, and finding the domain of those. So hopefully after this lecture, you'll be able to do those things. So a relation is a relationship between two set values. So in mathematics, we usually have a relation is between an x value and a y value of an ordered pair. We call the x values our domain, and the y values are called our range. So in order for a relation to be a function, it's a function if for every x value in the domain, it gives us back exactly one y value in the range. So if x is in our domain, if we plug it back into our equation, it can only spit out one value of y in our range. If we plug in an x value into our function, and it spits out our equation, and it spits out two or more y values, then it's not considered to be a function. So you had some time to think about an example of a relation that is a function. Define the domain and the range of an example. So an example could be going to the gas station. If you went to the gas station and you decided to pump, let's say, just the unleaded 87% octane level gas into your tank at one gas station, then the number of gallons that you pump in is going to be our domain, and our range is going to be the cost. So it wouldn't make sense for our domain to pump negative gallons into our tank. And so we would know that our domain, all the values that we could plug in would be 0 gallons or a little, not including 0. So it's putting a little bit in to how many gallons your gas tank holds. You don't want to fill it over that. And then you could look at the different costs. Well, unfortunately, you're not going to get money back when you're pumping gas into your tank. You're going to be paying money. So the cost is never going to be negative. It's always going to be greater than 0. So that is an example of a function. So I can take the same example and I can make it so it's not a function. So let's say we go to the gas station by the school and we go to the tank or the gas pump and we decide that we want to pump in 5 gallons of gas. Well, depending on what type of gas you decide to pump in your car, depends on what cost that you're going to get back. And so if you're just thinking about the different costs of that one pump, there's going to be usually three different outputs, depending on, is it 87 grade, 89 grade, or higher? So that would be an example of a relation that is not a function. Similarly, the domain and range of that example is going to be the same. How many gallons we pump in is our domain, and the cost would be our range. So here's an example of a function, and let's read through it and let's determine what the range and the domain of our relation is. We're going to express the relation using a mapping, and we're going to express the relation as a set of ordered pairs. So the following example states, The density of a gas under constant pressure depends on the temperature. Okay, so density of gas depends on temperature. Holding a pressure constant at 14.5 pounds per square inch, a chemist measures the density of an oxygen sample at temperatures of 0, 22, 40, 70, and 100 degrees Celsius. And he obtains the density of 1.411, 1.305, 1.229, 1.121, and 1.031 kilograms per meters cubed, respectively. So looking at this, what is the domain? And we want to know what is the range. So the density of gas, it's depending on the temperature. So the domain in this case is equal to the temperature. And in our case, they're using 0, 22, 40, 70, and 100 degrees Celsius. The range, that is our output. So depending on the temperature, depend on the density. So the range is the density. And in our case, we got back 1.411, 1.305, 1.229, 1.21. Actually did that wrong. 121. And 1.031. So express this as a mapping. So technically a mapping will have one set. We have our domain 0, 22, 40, 70, and 100. And these are mapping to our range. So just writing down the numbers in our range: 1.411, 1.305, 1.229, 1.121, and 1.031. So mapping 0 goes to 1.411. When we had 22 degrees Celsius, we had 1.305. 40, 1.229, 70 is 1.121, and 100 gives us 1.031. So this is an expression of what a mapping could look like. And then express this relation as an ordered pair. So basically these we are expressing as points. So if we chose it to be x, when x is 0, we have a y value of 1.411. 22, 1.305. 40 is 1.229. 70 gives us 1.121. And the last one is 100, which gives us 1.031. So we express this relation as a set of ordered points. So we have another example in front of us now. For the following problems, find the domain and the range of each relation, then determine whether the relation represents a function. So in one set, we have the level of education. We have a level of education less than ninth grade, 9th to 12th grade, being a high school graduate, some college, and a college graduate. And then we have the average income. And so average income for those who have less than ninth grade was 18,120,000. 9th through 12th grade is 23,251. High school graduate, $36,055. Some college is 45,810, and college graduates are 67,165. So notice that for each input, this is our domain, it corresponds to one output in our range. So our domain is the level of education, and our range is the average income. And this is a function. So the next example, we have some people, Elvis, Colleen, Kaylee, and Marissa, and we have their birthday. Elvis's birthday is January 8th, Colleen's birthday is January 8th, Kaylee's birthday is March 15th, and Marissa's is September 17th. So our domain are these 4 people. And our range are the birthdays. So looking at this, do you think this is a function or not a function, and why? Let me give you a minute to think about that, and I'm going to pause the recording while you guys answer. Okay, so feedback from the class was this was not a function, but this actually is a function. So recall, to be a function, for every input, it spits out one output. So Elvis, he only has one birthday. His birthday is January 8th. Okay, so that is okay. Colleen, she also only has one birthday, which is January 8th. Kaylee is March 15th, and Marissa is September 17th. So since every person only has one birthday, this is a function. So it's okay that 2 different people have the same birthday. We'll see that this is not a one-to-one function later on in this course because there's 2 different inputs that give us the same output, but this is a function. So one more example similar to this. So we have father and we have daughter. So our father, we have Bob as a father, John as a father, and Chuck is a father. And then daughters, we have Beth, Diane, Linda, and Marcia. Bob has 2 daughters, Beth and Diane, and John has 1 daughter, Linda, and Chuck has 1 daughter, Marcia. So would this be a function? Yes or no? Our domain would be the fathers, and the range is our daughter. So for my class, thumbs up if it is a function, thumbs down if it's not a function. And I'm going to pause while you guys vote. Okay, so good job. You guys got that this was not a function. And it's not a function because we have at least one input, in this case, one input that gives us back more than one output, which is Bob. He has one daughter, Beth, and he has another daughter, Diane. So Bob, the input, has two separate outputs. So this is not a function. So you should be able to look at sets like this and their mapping and tell if it's a function or not. But you should also be able to look at ordered set of points and see if they're a function or not. So looking at the ordered set of points of 2, 6, the point -3, 6, the point 4, 9, and the point 2, 10. Do you guys believe that this is a function or not a function? Okay, so we're looking to see if our domain, so maybe doing a mapping sometimes is helpful to see. Our domain in this case is the x values. So our domain would be 2, -3, 4, and 2. And the range are outputs, which are 6. I have 6 already written. I don't need to write it twice. 9 and 10. So 2 maps to 6. So that input of 2 gives us back 1 output. So that's good. -3 goes to 6. So this one input of -3 spits out 1 output of 6. 4 goes to 9. And 2 goes to 10. So for every input, that input gives us back 1 output. So yes, a function. But the next case scenario, we have the points -4, 4, -3, 3, -2, 2, -1, 1, -4, 0. So our domain in this case, again, are our x values of our point, -4, -3, -2, -1, and -4. I'm not going to write -4 down in my domain twice. So I'm not going to write that again. And my range are my y values, my output, which in this case are 4, 3, 2, 1, and 0. So -4 goes to 4 from the first point, -3 goes to 3 for the second point, -2 goes to 2, -1 goes to, that should be 1. And then -4, this also goes to 0. So function or not a function. So there's one case scenario in here where one input is not giving us 1 output. So -4 gives us back 2 separate outputs. -4 gives us back more than 1 output, so this is not a function. Okay, my error. Looking back up to the first example of the ordered set of points. Notice that we have 2 in here twice. I shouldn't have written this down twice. So I have the point 210 and I have the point 26. And so 2 is mapping to 2 separate numbers. 2 goes to 6 and 2 is also going to 10. So not a function. So great. I'm glad that you guys noticed that, and thank you for stating something. So you guys were correct there. So both of these are not a function. Okay, so we just looked at examples of mappings to see if the mappings were a function or not, given a set of ordered points, being able to tell if that was a function or not. Now we're given equations and we want to know, is our equation a function or not? Well, our first equation is y is equal to the cubed root of x. So thinking to yourself, if you plug in a value for x for this function, well, it might not be a function, for this equation, y equals the cubed root of x, would we get back one output or would we get back multiple outputs? And so that can help you to determine if it's a function or not. If it helps you, you can always thinking about plotting points. So for instance, if you plugged in 0 for x, well, I would get the cubed root of 0, which is 0. So one input 0 gives me one output 0. So that is holding true that it's a function. If I plug in 1, the cubed root of 1 is just 1. If I plug in 8, the cubed root of 8, what I cubed to get 8 is 2. If I plugged in -1, what I cubed to get -1 is -1. So I can't think of any example that I could plug in there for x and get back multiple numbers for y. So this is a function. So the next example, we have y is equal to 3x minus 1 all over x plus 2. Same kind of reasoning. For every value I plug in here for x, I'm only going to get back one value for y. Right? So if I plugged in 0 for x in here, I would get 3 times 0, which is 0, minus 1, which is -1 in my numerator. And if I plug in 0 into my denominator, I get 0 plus 2, which is 2. So my input of 0 is giving me one output of -1/2. If I plugged in 1 for x, I would get 3 times 1 is 3, minus 1 is 2 for my numerator, all over 1 plus 2, which is 3. So if I plug in 1, I get back one output of 2/3. So any number I decide to plug in there for x should give me one output for y. If you look at this though, there is a value that you would have to exclude from your domain. What can x not be for this second equation? So what would make that undefined for that equation? What value of x? So the value that x can't be, we can't have 0 in our denominator, and we'll look a little bit more of this after our break, but x plus 2. So x plus 2 cannot equal 0. So x cannot be -2. So we'd have to exclude that value from our domain, because if I plugged in -2 into that equation, I don't get back a number that's defined. It's undefined. Looking at the absolute value of y is equal to 2x plus 3. Would that be a function or not? So if your equation is not solved for y, y is not by itself, then you're going to want to solve for y. So we need to think about how would we get rid of those absolute values? Well, there's two separate equations that we could get. We could get what's inside the absolute value is equal to 2x plus 3. And y could also equal to the negative of what's inside the absolute value, because if I took the negative of what's inside the absolute value, that would become positive. So y could also equal negative 2x plus 3. And so in this example, if I plug in x, well, there's two separate equations for x. So for instance, if I plugged in 0, well, if I plugged it into the first equation, I get 2 times 0, which is 0 plus 3 is 3. But if I plug in 0 into the second equation, I would get 2 times 0 is 0, plus 3 is 3. But 3 times that negative in front would give me back negative 3. So here's an example where one input is giving us back two separate outputs. So this is not a function. So same as the last example, we don't have y by itself. We want to get y by itself. And so we could do so by isolating the term with y. So we could subtract x squared on both sides of our equation. We would get that negative 4y squared is equal to 1 minus x squared. We could divide both sides by negative 4. So we get y squared is equal to 1 minus x squared over negative 4. We can get y, get rid of the square by using the square root method, take the square root of both sides. But recall when we take the square root of both sides, we have to put plus or minus in front of one side. So we get y is equal to plus or minus the square root of 1 minus x squared all over negative 4. So notice for one value that I plug in here for x, there's going to be times where I'm going to get back multiple values for y. And so this is not a function. So if you're given an equation to determine if it's a function or not, think about if I plug in a value for x, am I getting back more than one value for y or not? If my equation wasn't in the form of y equals, then I would get it in the form of y equals to help me figure out if it was a function or not.